Now, conics are things that, like a circle, like an ellipse, a hyperbola that goes like this. Pieces that we can take out of this cone. If you cut your hyperbola, if you cut this slice here, you almost like kind of do a 3D type of thing. If I cut the cone, here's your cone, and I cut it a slice in the middle, I can make that elliptical because your cone goes like this. So it kind of has the effect, if I just took a slice out of here, I can get an elliptical type design. Because your cone is round around the edges, or I can get a circle or something like that. I don't need you to know where these come from. I just kind of want you to know what we're looking at in terms of conics. Your old favorite parabola is the first thing we're going to do. And you can get a parabola by cutting through this as well. That is not as important as this, that you see the difference between the circle, ellipse, versus a point, a line, something like that. I just put that there to kind of just like give you a clue of what we're going to look at. Now, we kind of did this equation when we were finding the equation of your circle, when we were finding the equation of your parabola. If you remember, here's your ax squared plus bx plus cy squared. You kind of remember seeing two of these things for your circle. Remember seeing this part, dx, ef, dx, dy plus f. Remember seeing that part for your circle. Remember seeing just this part for your parabola. We kind of like where we were parabola fitting and circle fitting. We kind of looked at that standard general equation. Now, what you probably remember is a vertex equation. Now, when we do your vertex equation, we kind of just separate this a little bit differently. We're going to pull out of that general equation a standard equation of your parabola. Your parabola that, ooh, the pens are all off. Okay, the parabola that you usually use is this one. Okay, in this case, if there's an x squared, there's obviously no y squared. So that guy's added there, you just get the c. The bx would have no y, you get the bx. So you kind of use this general format, and you've used this part of your parabola. Today we're going to put it into a vertex form of your parabola, where your vertex is always hk. And we kind of did this when we looked at transformations. When we did the transformations of your parabolas, we can see it in here. We kind of did these a little bit, but we kind of did them like this. X minus 2 squared plus 3. We kind of wrote them like this, so that it almost looked like a parabola going on here. If we move this over, you get your x squared to one side, you get your y to the other side, so y minus 3. And if I just switch this around, reflexive, excuse me. I'm not used to talking so much again. If we did this reflexive, really, if we did this reflexive thing, you notice it's kind of looking like this almost now. I just didn't have the y minus k thing here. Do you notice it kind of looks like this? This was your vertex form that we did. And we were able to pull out your vertex, your 2, 3. And we kind of did your transformations off of this. We took your parabola, we shifted it 2 to the right, and then we shifted it up 3. Remember doing the transformations off of your regular parabolas? We started like this, parent one. She said, okay, this goes horizontal, opposite way, 2 to the right, up 3. There's your vertex, 2 to the right, up 3. So we kind of looked at this form before, only we're just going to be a little bit more standard now when we set this up. Now notice, this is where your square is going. If this is where your x squared is, and your y squared, this parabola is either going to open up or down. This parabola is going to open sideways. Okay, so we're going to have a little bit more of a standard look to your parabola. Once you get used to seeing this way, it really makes a lot more sense to look at your parabola like this. I'm really not big on trying to memorize which way everything's going. The most important part you're going to see is the p-value, that p-value, your focus minus your vertex. But once we sketch this out, and I think on your papers I kind of sketched it out a little bit for you, so that you could kind of look to see which way this is going. Notice how I sketched it out for you so you could see. I'm going to drop this down and take a look at it down here. You have this sketch as well. When P is positive, let's just rewrite this. Remember your vertex is the HK thing. H is always associated with the X. Notice, like, even if it's on the side, even if it's on this side, the X is here. Notice that the H is always with the X, the K is always with the Y. And your vertex point always falls HK. Now, P is important in this. This is going to help you set this up. The P is this. The distance from the focus to the vertex, right here. That's the distance of P. It is the same distance from the vertex to a directrix line. All it's saying is this. Here's my little parabola. My parabola goes like this. My parabola has a vertex. It also has a focus point. The focus point is inside my parabola. My directrix is equidistance on the other side. So if my focus is up 1 unit here, my directrix would be down 1 unit here. There's a little equation that we use to say that the distance from here to here is the same as the distance from this directrix line to here. And it kind of works off that. It has the same distance, but I'm not really concerned about that part. What I want you to realize is that these are equal distance apart. Your vertex is smack in the middle, in other words, between your focus line, your focus point, and your directrix line. It is a little bit different than looking at this. Put an asterisk by here. That's important. If you notice, and I kind of did, if P is positive, if P is your positive number, and X squared is on the side, your left-hand side, it's going to open up. Same way you had before when you saw this. If this was positive, your parabola opened up. So when P is positive with an X squared, it's opening up. When P is positive, when your Y squared is here, if this P is positive, it's opening to the right. Because the Y squareds will open right and left. Okay? If P is negative here, it's going to open down, just like this, when we did this equation. The parabola says it's negative in the front, open down. We use that as A before. Remember the A? And we tested the value of A. Now, since we're changing your format a little bit, we're going to test the value of P. It's a little bit confusing when we start this, but once we do one together, it won't be so bad. Please put your phone back. I need your guys' attention through all of this. Now, if we have this, obviously when we do this, you're looking at a vertical axis of symmetry versus here, a horizontal axis of symmetry. Okay, kind of makes sense, right? It kind of wraps around your parabola that way. I'm really not big on memorizing which way this goes, because once we find your P, we can kind of figure that out. Like all of these, where your axis of symmetry is, you can kind of figure that out once you get your pieces in place. So I'm not the big person on memorizing. We're just going to more or less get a feel for this. So I think the best way to start this is just to do one with you. It's a little bit more confusing looking at it. You're going to see it's not so bad once we get it started. And it kind of falls into place. All right. So we're going to sketch this. Now, just looking at that equation, how do I know if this is a line, a parabola, a circle? The square. There's only one square in here, and that's at the y. So one square tells me parabola. If you did your ax squared plus bx plus c, obviously this is a little bit different because the y has the square. So let's set this so that the y squared is on the left-hand side. Let's move this guy over. As a grouping, let's just move him over. We want the negative sign to stay in front of that. This is your y minus k. I'm just going to write this underneath it for a minute. This is your 4p x minus h. Kind of get used to what that formula looks like. Now, we know it's a y, so it's either going to open left or right. Now, to do that, we look at the p. Here's where my p-value is, this guy right here. Is my p-value going to be a positive or a negative? Look at this guy right here. So what's my p-value going to be? Negative. So it's a negative p. I don't know what it is yet, but I just know it's negative. So therefore, it's going to open left. It opens, if it's negative, it opens towards the negatives, left. If it's positive, it opens towards the positives, right. Now, find me your vertex. What's your vertex of this parabola? Line it up here. Remember, it always comes out the opposite way, just like your circles. -3, 2. Okay, because if I took this and I did this, 3 is equal to -h. I divide by a -1, therefore h is equal to -3. I take this one, just like you read it. -2 is equal to -k. I divide by a -1, and k is equal to 2. And your vertex says hk. So far, I know this about my parabola. It has a vertex of -3, 2. So out here, -3, 2. Here's my vertex. And which way is it opening? The left. Left. So I know this. Okay? I know that much about my vertex. Now, my focus has to come inside, and it has to sit on this line right here. This is my axis of symmetry. So I want you to think for a minute, if this vertex point is -3, 2, what is your axis of symmetry? Well, what's the equation? I need a line that goes like this. Y equals 2. See where Tatiana got that from? My axis of symmetry. So there's your y equals 2. Your focus and your directrix are going to come off of this line. Well, your focus is going to come somewhere in here, and your directrix has to come an equal distance and be somewhere right here. The directrix is going to be the x-equal line this time, because I want a vertical for my directrix. The focus is a point, the directrix is a line. Okay? Now, we said the distance between my vertex and my focus is p. And we also know that p, God bless you, does p have to be positive or negative? Negative. We're opening left. So it is this easy to find p. Line these up and set them equal. And solve for p. So p is -1/4. We knew p would be negative, it's opening left. So our goal now is to take each value, the x or the y, and add and subtract 1/4 to it. I need to move this way horizontally. So I'm going to take the x value, negative 3, minus negative 1/4. I'm going to add and subtract 1/4 from it. So if I subtract 1/4 from it, I'm going backwards. I'm going to my directrix. What would my answer be? This would be negative 3 plus 1/4. Just think about it for a second. Negative 2 3/4. Good. And now I'm going to take negative 3, and I'm going to add negative 1/4 to it. And it would be negative 3 1/4. Okay? So my focus point is going to be which one of those? Negative 3 1/4, comma, 2. And my directrix is going to be x equals what? Negative 2 3/4. See where we went with that? Okay. Why did I do what? How did I took? We said, here's my vertex. My f is the distance between here and here is the distance of p. So, and then this is also equal distance to p over here. So if my p is negative 1/4. If I add and subtract negative 1/4 to negative 3, when I subtract it, I'm technically adding because it's the opposite, add. So I moved back this way. When I added it, I added another negative and got me to the f point. Okay, now, let me just give you the formula for the focus that we just did. The focus is h plus p k. Now, this is why I really am not in the memorizing rule. I'd rather do it this way. H is my negative 3 plus p, my negative 1/4, k, 2. So negative 3 1/4, 2. Didn't we get that just by using our diagram? Did we have to memorize that formula? No. My directrix, in this case, if you look at the page before this, your directrix is h minus p. H is my negative 3 minus a negative 1/4. This gives me my, take the opposite and add my positive, my negative 2 3/4. So therefore, x is equal to negative 2 3/4. Didn't we get that just by using our diagram? Okay. If you like to memorize formulas, memorize them. If not, use your diagram. Your focus is engulfed inside your parabola. It's inside the parabola. Your directrix is the equal distance away from your vertex point, but your directrix is a line. So basically, anytime we go out like this and then down to our line, we know they'll all be equal. There'll be equal distances every time we go up and down to our line. We don't have to know that. But you do have to understand how to set this back up into this format, how to find your P, and how to find your focus, your directrix, and usually your intercept. Let's talk about an intercept for a minute. I can pretty much sketch this, but I just don't know where this point will be right here. That's my x-intercept. So to find my x-intercept, do I set y equal to 0 or x equal to 0? Y. So I'm going to come here and use either one of these. Sometimes it's easier to just go into that one. Sometimes it's easier to take this equation and set y equal to 0, because on that x-axis, y is 0. So if I plug a 0 in here, I'll distribute this, make it easier. I distributed this guy, get rid of your parentheses. So a negative 2 squared is 4. Add 3, stay with me for a minute. So 7 is equal to negative x, therefore x is equal to negative 7. What? Okay? Therefore x is equal to negative 7. Does that make sense? That this point could be negative 7, 0, if this point is negative 3, negative 2? Yes, it fits in that it could be, right? It makes sense to us. Do I have to look for a y-intercept here? Nope, because I don't cross the y. If I put x of 0 in here, and I tried to do this, and I took the square root of this number, this is going to be my x of 0, my negative. It is not going to work for me, so it's not going to happen in this. I don't have a y-intercept for this one. Just an x-intercept. So this is the equation that we're looking for. And we're going to find your directrix and your focus from this. It's equal distance away from the vertex. And I realize you guys are not usually used to seeing a y squared out there. That throws you off too. This is probably your first time with y squared, right? Because your parabola can open sideways. Is that parabola a function? No, doesn't pass the vertical line test. No vertical line test for that guy. But we can still sketch it and find its vertex and everything we need to find. Ready to try one more? Be brave. Okay, one more. Now, this should kind of resemble your one that you know in law school. Now, is this parabola going to open up, down, left, or right? Up. Everybody says up. Okay? Everybody says up. So now, let's get this in your standard format. I'm just going to switch these around for a second because we want the x squared on the left-hand side. It's much easier to start like this. Much easier to start that way. Now, you need to get the x squared by itself. The p goes on the other side. So whatever's in front of this, even if this has an x minus 3 squared, whatever, you still got to get rid of that too. So we're going to divide both sides by 2. And you can always put this in your calculator and take a look at your parabola. You know that that 2 makes it a little bit tighter. That's your transformation. A dilation of 2 stretches it up when we did your dilations. So we know it's going to look like that. So we're going to get x squared equals 1/2 y. Now, here's your situation. Okay. Tell me what your vertex is. Tell me what your vertex is. Well, think about this side. If you put that in your y equals, where would your vertex be? 0. At the 0, 0, right? Look, right now I have nothing in here, so isn't that x minus 0? Isn't this y minus 0? Because I have no parentheses there. So my vertex is 0, 0. Make sense out of this, because it totally works better for you if you make sense out of it. Like, even pre-sketch this. You can put the y equal in your calculator, just so that you understand where this is going. So here's my vertex at the 0, 0. I know we're opening up somewhere. But how did I know we're opening up? It's positive. And look at this right here. There's how I find out my p. Okay? Is my p going to be positive or negative? My p is going to be positive, right? So now I have to find out what my p is. So I pull this out and I divide. 1/2, keep, change, flip, this over. So P is equal to what? 1/8. Yep. It's a very tiny distance up and down. Now, of course, we're sketching this, so you can just make it look like this and this. And we know that this distance is going to be 1/8. And this distance right here is going to be 1/8 off of 0, 0. Now, without using your formulas, see if we can get this. This guy is changing which value when it drops down and up, the x or the y. The y, the x is staying the same, right? So let's go for our focus. What's your focus going to be? 0, 1/8. I only moved 1/8 up. It has to be 1/8 up, 1/8 down. My directrix line, is this going to be an x equal or a y equals? Y equals, therefore I want the y value. When I drop down 1/8, what's my y going to be? -1/8. So I know my focus, I know my directrix. Now, if you go back to your formula and you take your directrix out of here and you use your formula, K0 minus, this is +1/8. You found P to be +1/8. There's the equation of your directrix using your formula. Do we need to? If we can look at our graph and say, well, it's got to go down 1/8. Just get the motion of which one's changing, x or y, and that's just going to help you tremendously. Your focus point is the same thing. Your focus point says, if you take a look at your equation, for your x equals, your focus point says h, k plus p. So what's the h in this case? hk, you're here. 0, and 0 plus p is 1/8. Didn't we get that? I don't memorize the formulas either. I just look at the graph. It makes much more sense if you look at your graph. So now, you can kind of sketch this. Does this have an x or a y intercept that we have to worry about? It only has one intercept, and that's at the origin. That's where your vertex is. So we don't have to worry about setting x equal to 0, setting y equal to 0, because we know it's going to cross at the 0, 0. Now, how do I know how wide to make this? It's just kind of like you're sketching. And you know that the 2, this is your dilation. Your 2 kind of stretches that. It changes the distance from 0. Pulls it up. It gives it a stretch. When we did this using your transformations, we did your vertex form. We put it in a little bit of a different form this time, because instead of saying the plus on that side, we just moved that part to the other side. All we did was move it over. So you're going to look at your parabolas, and you're going to see if they open up left or right based on which one is the square.